The world is on the cusp of a remarkable energy transformation. Traditional fossil fuels are facing growing scrutiny. Climate change concerns and the need for energy security are driving innovation. Fuel cells are emerging as a beacon of hope in this evolving energy landscape. They offer a cleaner, more efficient, and sustainable way to power our world. Fuel cells are electrochemical devices that convert chemical energy directly into electricity. Unlike conventional combustion engines, fuel cells produce minimal emissions. They offer the potential to dramatically reduce our reliance on fossil fuels and mitigate their environmental impact. As we enter this new energy era, fuel cells hold immense promise. They represent a paradigm shift in energy generation and consumption. This essay will delve into the exciting world of fuel cells, exploring their current applications, recent breakthroughs, and the transformative future they hold. Fuel cells operate on a simple yet elegant principle. They combine hydrogen fuel with oxygen from the air to produce electricity, heat, and water as a byproduct. This electrochemical process is clean, efficient, and remarkably quiet. Fuel cells offer several advantages over traditional energy sources. They are highly efficient, converting a larger proportion of fuel into usable energy. They produce zero harmful emissions at the point of use, making them an environmentally friendly alternative. Fuel cells are also remarkably quiet, eliminating the noise pollution associated with combustion engines. The versatility of fuel cells is another key advantage. They can be used in a wide range of applications, from powering vehicles and homes to providing backup power for critical infrastructure. Their scalability allows them to be deployed in various sizes, from small portable devices to large power plants. Fuel cells are no longer a futuristic concept confined to research labs. They are already powering a variety of applications in the real world. Companies like Hyundai, Toyota, and Honda have made significant strides in commercializing fuel cell electric vehicles, FCEVs. Hyundai's Nexo SUV, for instance, offers a compelling glimpse into the future of zero-emission driving. With a range of over 370 miles and fast refueling times, the Nexo demonstrates the practical viability of FCEVs. Toyota's Mirai sedan and Honda's Clarity fuel cell are other notable examples of FCEVs gaining traction in the market. Beyond transportation, fuel cells are finding applications in stationary power generation, providing clean and reliable electricity to homes and businesses. Bloom Energy, a leading fuel cell manufacturer, has deployed its solid oxide fuel cells, SOFCs, in various settings, including data centers, hospitals, and universities. The field of fuel cell technology is constantly evolving, with researchers and engineers pushing the boundaries of efficiency, durability, and cost-effectiveness. Recent breakthroughs in materials science and design have led to significant improvements in fuel cell performance. One notable area of advancement is the development of new catalyst materials. Platinum, a precious metal, has traditionally been used as a catalyst in fuel cells. However, its high cost and limited availability have spurred research into alternative materials. Scientists are exploring the use of less expensive and more abundant materials, such as nickel and cobalt, to reduce costs and improve the commercial viability of fuel cells. Another promising area of innovation is the development of new membrane materials. The membrane is a critical component of a fuel cell, responsible for conducting protons while preventing the mixing of hydrogen and oxygen. Researchers are developing new membrane materials that are more durable, efficient, and resistant to degradation. As fuel cell technology matures, its cost is steadily decreasing, making it an increasingly attractive alternative to traditional energy sources. Advances in manufacturing processes, economies of scale, and the use of less expensive materials are all contributing to this downward trend in cost. The declining cost of fuel cells is having a profound impact on the market. As fuel cells become more affordable, they are becoming accessible to a wider range of consumers and businesses. This is driving increased adoption across various sectors, from transportation and power generation to portable electronics and backup power systems. Governments around the world are also playing a role in accelerating the adoption of fuel cells. Incentives, subsidies, and regulations aimed at promoting clean energy technologies are creating a favorable market environment for fuel cells. As the market continues to grow, we can expect to see even more innovative fuel cell applications emerge in the years to come. Fuel cells are poised to play a transformative role in the future of transportation, offering a clean and efficient alternative to gasoline-powered vehicles. FCEVs offer numerous advantages over their combustion engine counterparts, including zero tailpipe emissions, long driving ranges, and fast refueling times. While passenger cars are a prominent application for fuel cells, the technology's versatility extends far beyond. Fuel cells are also being explored for use in heavy-duty trucks, buses, trains, and even ships. These applications are particularly well-suited for fuel cells, as they often involve long distances, heavy loads, and the need for reliable and efficient power. Several prototype and concept vehicles showcase the potential of fuel cells in various transportation sectors. Hyundai, for example, has developed a fuel cell-powered truck with a range of over 500 miles, demonstrating the technology's viability for long-haul trucking. Alstom, a global leader in rail transportation, has developed a hydrogen-powered train that offers a clean and efficient alternative to diesel locomotives. The widespread adoption of FCEVs hinges on the development of a robust hydrogen refueling infrastructure. While significant progress has been made in recent years, the availability of hydrogen refueling stations remains a key challenge. Governments and industry stakeholders are working together to address this infrastructure gap. In many countries, initiatives are underway to build out networks of hydrogen refueling stations, particularly along major transportation corridors. These efforts are essential for making FCEVs a practical and convenient option for consumers. The growth of the hydrogen refueling infrastructure is expected to accelerate in the coming years. As more FCEVs hit the road, the demand for refueling stations will increase, creating a positive feedback loop that drives further infrastructure development. This expanding infrastructure will make it easier for consumers to embrace FCEVs and contribute to a cleaner transportation future. Fuel cells have the potential to revolutionize not only transportation, but also the way we generate and consume energy. They offer a clean, efficient, and reliable alternative to traditional power plants, with the potential to significantly reduce our reliance on fossil fuels. Fuel cells can be used in a variety of stationary power generation applications, from providing electricity to homes and businesses to powering critical infrastructure such as hospitals and data centers. Their scalability makes them suitable for a wide range of power needs, from small-scale residential applications to large-scale industrial facilities. The use of fuel cells for stationary power generation offers numerous benefits. They produce zero emissions at the point of use, reducing air pollution and mitigating climate change. Fuel cells are also highly efficient, converting a larger proportion of fuel into usable energy than traditional power plants. This efficiency translates into lower energy costs and reduced greenhouse gas emissions. While the future of fuel cells is bright, there are still challenges to overcome. The cost of fuel cells, while decreasing, is still a barrier to widespread adoption. The development of a robust hydrogen infrastructure is also crucial for the success of FCEVs. Durability and longevity are other areas where fuel cells continue to improve. Researchers are constantly working to develop more durable materials and designs that can withstand the rigors of real-world use. As technology advances, we can expect to see even more durable and long-lasting fuel cells emerge in the market. Despite these challenges, the opportunities presented by fuel cells are too significant to ignore. As we transition to a cleaner and more sustainable energy future, fuel cells will play an increasingly vital role in powering our world. The future of fuel cells is not some distant dream, it is unfolding before our eyes. From the streets of our cities to the power grids that sustain our lives, fuel cells are already making a tangible difference. The growing number of FCEVs on the road is a testament to the technology's viability. As production scales up and costs continue to decline, FCEVs are becoming an increasingly attractive option for consumers seeking a cleaner and more efficient mode of transportation. Beyond transportation, fuel cells are quietly powering homes, businesses, and critical infrastructure around the world. Their reliability, efficiency, and environmental friendliness make them an ideal choice for a wide range of applications. The transition to a cleaner, more sustainable energy future requires a collective effort. Governments, businesses, and individuals all have a role to play in embracing and promoting fuel cell technology. Governments can incentivize the adoption of fuel cells through subsidies, tax breaks, and regulations that promote clean energy. Businesses can invest in research and development, bringing innovative fuel cell products to the market. Individuals can make conscious choices to support companies that are leading the way in fuel cell technology. The future of energy is in our hands. By embracing fuel cells, we can create a world where clean, efficient, and sustainable energy is available to all. The time for action is now. Let us join the fuel cell revolution and power a brighter future for generations to come.